In this video, we will see an example of comparing means without calculations. We're given 4 distributions labeled A, B, C, and D, which are represented below by their histograms. Each distribution is made of 9 measurements. We need to order their respective means, mu sub A, mu sub B, mu sub C, and mu sub D, without performing any calculations. To begin this task, I always look for 2 distributions that look almost identical. And when I look at distribution A and B, I see that the right and middle side of this distribution, they look identical. The only difference between them is that element that used to be at 3 for distribution B moved to 2. This difference of 1 unit, where here I see a 2 in distribution A versus 3 in distribution B, makes the mean of the first distribution smaller than mean of the second distribution. I can conclude, therefore, that mu sub A is less than mu sub B. I continue investigating the remaining histograms. And when I compare histogram A with histogram C, I notice that they're also almost identical. 2 is same here. Elements at 10 and 11 are same. The only difference is that element that used to be at 7 in histogram A shifted to 5 in histogram C, which makes mean of histogram C smaller than the mean of histogram A. Therefore, I can add one more inequality symbol and say that mean or mu sub C is smaller than mu sub A. Now I need to decide what relationship the distribution D has with respect to the other 3 distributions we already discussed. I'm going to do that by comparing distribution C with distribution D. How are they same or different? I notice that elements at 11 and 10 and 8 and 6 are all same. So up to here, all of this is same. The only difference between histogram D and C is that this element moved from 5 to 3, from 5 to 3 in histogram D. So I, again, compared to histogram C, I have a smaller element in this position right here compared to the previous element at 5, which makes the mean of the last distribution D being the smallest one of all. I'm going to conclude that and say mu sub D is the smallest value. This is my final decision. Mu sub D is less than mu sub C, which is less than mu sub A, which is less than mu sub B.